Hey everyone and welcome back. In this video we are going to start adding the encryption library to the current MiniChatClone. So one more time I'm going to ask you, if you haven't watched this MiniChatClone tutorial or cryptography, go ahead and watch the tutorials, otherwise you won't understand what's going on and how is everything happening. So basically what I'm doing, I'm going to clone this MiniChatClone application inside my Android Studio, and then I'm going to add a new branch and name it security. So in this branch, we are going to handle the cryptography and secure signaling. So right now, what I'm going to do is going to download this source Android Cryptography and add this Android Cryptography library inside my current project. Actually, what I need is this Android Cryptography library. Let's go ahead and copy and paste it inside my current project here. I'll name it cryptography. Make sure that the package name fits your current package name. So far so good. But I need one more library to have these cryptography classes, which is the Bouncy Castle library. Let's go inside libs.versions.toml, add the version number here, and then copy and paste the library here. And of course, inside the build.gradle file, we have to make sure that we are adding the added library here, Bouncy Castle. Let's press sync and make sure that this cryptography part is added to our library right now. So if we go inside our main activity and try to access CryptoSession, you should be able to see that this CryptoSession is being added to our project right now. So as we discussed about it, the first thing that each user that is going to be online is doing right now is to publish his own public key. To do that, let's go inside the FirebaseClient, inside remote package. So let's remove everything that we don't need here. Inside the FirebaseClient, we are going to have a function that is going to update its own public key. So let's write private suspend fun update self public key, which is going to get a public key of type string. And we are going to use the database reference and with the child of Firebase field names dot users inside the child of pref helper get user ID, and inside the child of public key Firebase field name and public key that we should add it here. This is going to be camel case public key and the ID is public key. We then want to set the value of the public key to the string version of public key and then press await to make sure transaction is successful. And one more function is to fetch the target's public key using its ID. We'll have the suspend fun get user public key using its user ID of type string, and it will either return string or null. So you'll return a try with a catch of type exception, and we will return null, but before that we will try to print stack trace. So inside the try block we will use the snapshots using database.child Firebase field names with the name of users inside the child of user ID, and inside the child of Firebase field names dot public key we want to call get and press await. So right here we will use the snapshot and get value and pass string class as the blueprints. Simple as that. So up here, when the user starts observing the incoming messages, before updating status to looking for match, we need to update our self public key with the public key. But since I haven't created this KeyPair, I'm moving up here and creating a private val KeyPair is going to be CryptoSession object that I don't have here. Let's create it first. Private val CryptoSession of type CryptoSession. For now, we will use the CryptoSession implementation constructor. You can use the dependency injection on this class and bind it using heals, but I'm not going to do that. So far, I'll just create the CryptoSession and get access to RSA service and generate an RSA KeyPair with the size of 2048. Right here, we will have the KeyPair base 64 string version of it, which is going to be CryptoSession gets RSA service and convert RSA KeyPair to base 64 string, and we'll pass KeyPair to it. So we right here have a pair of public string version, 64 string version, paired to the private one. So the first is always public. Right here, we have the access to KeyPair string. We use the first one to be uploaded to the Firebase. Now let's make sure that if user goes online, it's going to publish its own public key to the panel or to the Firebase. Bringing up the Firebase panel here, removing all the user to make sure that all of the data are new. Yep, as you can see, the public key is published to the panel. And now the user is looking for match. Before we move to the next video, I'm going to do one more thing here, which is going to be receiving the target's key. Of course that we have written a function already for it, but we have to handle it inside two situations. The first one is offerMatch and the next one is receiveMatch. In these two parts, as you can see, we have the access to the string ID of the participant. So in these two cases, we have to fetch the public key of each target. So up here, I'll create a private var participant public key, which is going to be of type public key of Java security library, and it's going to be null initially. Let's go down here inside offerMatch. We are going to wrap everything here inside a coroutine scope and launch a block into it. Then inside the offerMatch, we are going to use function getUserPublicKey and pass the participant ID to it and check if it's not null. Then we want to instantiate the public key of the participant using CryptoSession get RSA service and converts base 64 to public key, pass it to it. So using this function, base 64 to public key and base 64 to private key, we are converting back the base 64 version of the public key to the real public key object from Java security library. Also inside the receiveMatch, we want to do the same. So let's just copy and paste it here. Since we are inside the coroutine scope, we simply want to do a run block like this. Now that we have access to the participant's public key, it's time to start exchanging encrypted data right now. Let's move to the next video and handle whatever we need. Till the next video, see you everyone.